Hi everybody, welcome to physics teacher classes. We are learning laws of motion. In that we are learning how to draw free body diagrams and solving the equation for unknown quantities, right? So in our previous class we have seen simple pulley and connected bodies. Today let us learn some more things, right? So let us take another example. In this example, I am connecting a body of mass m1 through a string with the help of a pulley and another mass m2 to m2 with the help of another string. I connect m3. This is the situation. Okay, right. Now assume that the body is moving down, m3 m2, and m1 is moving up. Now see, in this case how many strings do we have? This is one and this is another one, right? Here two strings are there, therefore the tension in this string, let us take T1, and in this string T2. Okay, so as long as the string is same, tension will be same. Okay, here two strings are there, so that different tensions will be there in each string, and the whole will have an acceleration A downward and this one A upward. The acceleration of each block will be same, right? Now let us draw free body diagram for first body m1. So how many forces are acting? Two forces, we know that is m1g and T1. Okay, so from this we can write T1 minus m1g is equal to, what is that? m1a. That is the equation. Let us say this as equation 1. Next, for m2, on m2 how many forces are acting? One is gravitational force, that is equal to weight, and this string is pulling the m2 downward, that is T2, and the upward string is pulling it in the upward direction, that is T1. So what is the equation for that? T2 plus m2g minus T1 is equal to m2a. This is equation 2. Okay, na sir? These two are acting downward, we have add, so it is acting in opposite direction, minus. Now coming to m3. What is the free body diagram? How many forces are acting on it? Let us see. Gravitational force is downward and tension T2 is upward. Therefore, m3g minus T2 is equal to m3 into a. This is equation 3. That's it. Now, how many unknowns are there here? T1, T2 and a. How many equations we have? 3 equations. So that easily you can solve for variables. Clear? Right. Let us see another situation. In this situation, this is a table. For a table, a pulley is fixed here. Okay, a rope or a string is passed over the pulley, and here an object m1 is connected, and here another object m2 is connected. Okay, now m2 is moving down and m1 is moving in this direction. Suppose the tension in the string, let us take as T, because the string is same. Okay, acceleration of m2 is a and acceleration of m1 also will be a. Okay, now let us see free body diagram for m2 first. On m2 how many forces are acting? One is gravitational force, m2g, another one is tension. Tension always pulls the body, so that equation will be m2g minus t is equal to m2a. Let us say equation 1. Okay, these are the vertical forces. Now see that on this vertically the forces are balanced, there is no motion vertically, so we no need to take. Horizontally how many forces are acting on m1? On m1 this surface is frictionless, so that only one force is acting, that is T. Therefore T is equal to how much? m1a. This is equation 2. How many unknowns are there? T and a. So how many equations we have? 2. So that easily you can solve. Clear na? Right. Now let us consider another situation. Okay. Now in this situation, Suppose this is the surface. A man is standing on the surface and pulling the water with the help of a bucket connected by a string. Right? He is drawing water simply. Right, Nana? Next, so what is the normal force? In this case, we need to calculate. And another case, to pull the same bucket of water, now he is using a pulley. Okay? Now he is using a pulley. With the help of the pulley, he is pulling. In this case, what is the normal force? Let us calculate. In which case, normal force is greater. Let us see. Right, Nana? So, in the first case, okay, draw free body diagram for man. In the first case, draw free body diagram for man. Right. So, tension. First, it is acting downward. Yes. Next, gravitational force acting downward. Let us take mass is a m, so that mg. Next, what is the upward force acting? Normal, due to the surface. Understood, Nana? So these are the forces acting on the man in the first case. Yes or no? See that tension is pulling the man down, or tension always pulls the object. So we are drawing free body diagram for man. So tension pulls downward, gravitational force acts, and normal by the surface acts. Okay. And now what is the equation here? N minus of mg plus t is equal to 0, because there is no acceleration for the man. Therefore, in this case, n is equal to what? Mg plus t. Okay. Remember this equation. Here, normal force applied by the ground is equal to weight of the man plus t. Okay. It is greater than weight of the man. Yes or no? And now coming to second case. In this second case, draw free body diagram. Okay. This is, let us take the man. So here he is pulling the string. Okay. Then string pulls the body upward. So tension is in the upward direction. Gravitational force on the man will be downward direction. And normal acts in the upward direction. Okay. This is. Here he is pulling down the string. So that string pulls the man upward. Okay. And now in this case, what is that? N plus t minus mg is equal to 0. Therefore, n is equal to, what happens? Mg minus t. Yes or no? Yeah, see this. You observe carefully these two equations. Okay. In this case, n is mg plus t. Here m is mg minus t. So that in which case normal force is less. So in this case, normal force is this. This is the advantage of using pulley, so that he can apply less force on the ground also. Okay, na? So the force applied by the ground on the man is n, that is less in the case he is using the pulley. That is the advantage over the pulley. Clear? Next, here in this question, sometimes they may ask, what is the net force acting on the pulley? What is the net force acting on the pulley? So in this diagram, you observe carefully, tension is acting this side. Okay, coming to pulley, another tension is acting this side. Means this is the object, this is one force, this is another force. What is the resultant force? The resultant force will be in this direction. How much will be that? That is t root 2. Yes or no? Okay, now as this is 2 t and t, perpendicular direction 90. Okay, now the resultant will be how much? Root over t square plus 2 t into cos 90. So you will be getting t root 2 is the net force acting on the pulley. Clear this, Nana? Right. So these are the some of the situations. Next, let us see another situation. Okay, where there is a string or rope. Okay, on this a monkey is moving upwards. Okay, with an acceleration a, for example, a monkey is moving up. Okay, so it is climbing up the rope with an acceleration a. Now what is the free body diagram for the monkey? Now on the monkey, how many forces are acting? One is gravitational force acting downward. Okay, next, as it is moving up, okay now, as this monkey is moving up in this situation, now the tension is in the upward direction. So that what is the equation? T minus mg is equal to ma. Okay, so from this one can calculate tension in the string, tension developed in the string. So that tension is equal to ma plus mg. Clear, Nana? Very good. Now we are going to learn about apparent weight of the body. Apparent weight of the body. This is in the case of lift, or it can be called as elevator. These cases are very important. Means you are in a lift. Okay, so when the lift is moving up or when the lift is coming down, what happens to your apparent weight? Here apparent weight is nothing but normal force exerted by the normal force exerted by the floor of the lift. Okay na, floor of the lift. Now consider the first case, case 1. So you are in the lift, okay, right? Now the lift is moving up with an acceleration a. Clear? Very good. Now what is the free body diagram of this man? So on the man, how many forces are acting? Two forces. One is weight of the man acts downward, and normal exerted by the floor of the lift acts upward. Okay, now equation will be what? As it is moving up, n minus mg is equal to mass into acceleration of the lift. So that we can calculate n is equal to m of a plus g. This is the apparent weight of the man. Okay, that means here if you place any weighing machine, okay, the weighing machine records the apparent weight of the man, that is m of a plus b. Here n is greater than weight of the person, true weight of the person. See that n is nothing but mg plus ma. So here apparent weight of the person increases. That's why whenever you are moving in the lift upward, you feel some more weight. Okay na, it's a general feeling when you are moving in the lift upward. Understood? So when the person is moving up, not only person, an object is moving up in a lift with an acceleration a, then the force applied means apparent weight of the person increases simply. Okay na? Right. Now let us see case 2. Now the same lift and the same man standing on the floor, now it is coming down with an acceleration. Okay. Now in this case, what could be the free body diagram? Only two forces are acting, mg downward, n is upward. Now as it is moving down, mg minus t is equal to ma. Okay na? So in this case not t, it is n. Now mg minus ma is equal to n. Okay, therefore n is equal to m of g minus a. This is the equation. Now tell me in this case apparent weight is greater or less? Very good. Apparent weight n is less than mg because it is mg minus something. So the apparent weight of the person decreases. When you see your weight in a weighing machine placed in the lift, your weight will be reduced. Okay na? So in this way easily you can lose your weight. Yes or no? Yeah. So this is understood na? Right. Now let us see case 3. Okay. Now in this case someone cut the cable of the lift. Okay, if the lift cable is cut, what is going to happen is the body is going to fall with an acceleration which is equal to acceleration due to gravity. It is called as a freely falling body. What is that, Nana? Freely falling body. Now let us see what is the apparent weight of a freely falling body. Now if you draw free body diagram for man, again two forces mg and a normal force. Okay, as it is coming down, mg minus ma is equal to, what is that, m into a. Okay, so that mg minus n is equal to a is how much, mg. Therefore mg minus mg is equal to n. From this, n is equal to how much, 0. Therefore the apparent weight of the person or any object is 0 when it falls freely. Remember, this is important thing. The apparent weight of a freely falling body is 0. That means if you jump from a building, okay na, so your weight, apparent weight will be 0 at that moment. If you drop an object, what is its apparent weight? 0, because these all comes under freely falling bodies. So apparent weight of a freely falling body is 0. Clear na? Now let us see another case. Case 4. Now in this case, the lift is moving up with a constant speed. Okay, when it is moving with constant speed, what could be its acceleration? 0. Okay na? Then free body diagram is mg minus n. Yes nana? So that n minus mg is equal to ma is 0. Therefore n is equal to mg. Clear? If a body is moving with a constant speed, if there is no acceleration, then apparent weight is equal to true weight. Not only that, if the body is at rest, if the lift is at rest also, then this term will be 0, then n will be is equal to mg. Understood? Yeah. Now let us see some more interesting cases in this. Right, Nana? Okay. Now another case. Case 5. In this case, now the lift is moving up, okay, with a negative acceleration, with a retardation of a. Right, now in this case, means its speed is decreasing as it is moving up. Okay now? And now what is the free body diagram? That is mg and n. As it is moving up, n minus mg is equal to minus ma, because a is equal to minus a. Right now? So in this case, n will be is equal to what? Mg minus ma. So in this case also, n will be less than mg. Okay, so previously you have seen, as the lift is moving up with an acceleration, its apparent weight increases. Now it is moving up with retardation. This is equal to lift coming down with an acceleration. Yes, in that case also the equation is same. Okay, you see, right now? And now let us see case 6. In this, now the lift is moving down with a retardation, means while it is coming down, its speed is decreasing. Now let us see. Free body diagram is mg and n. So the equation is mg minus n is equal to minus ma. Therefore mg plus ma is equal to n. In this case, n is greater than mg. Okay na? So that the apparent weight is greater than mg. So this is equal to, the lift is okay, moving up with an acceleration. Moving up with an acceleration. Okay, understood Nana? So these are the possible cases some. Right? When a freely falling, what happens is, when a lift is freely falling, you will not be contact with this. Okay, you will be floating and you will be hitting to the top of the elevator or lift. Clear Nana? So in this way one can solve the problems based on free body diagrams, connected bodies, pulleys and apparent weight and so on. Clear? So you practice these, okay, and solve the problems whatever the books you have. Understood Nana? So these are the laws of motion. So we will meet in the next session with a different lesson. Thank you very much.